Right, let's continue. Right, now let's check on how to restrict our quadratic function. Let's say, for instance, you are being given y is equal to x squared. Y is equal to x squared, like that. And you are to sketch this graph. You are to sketch this graph. You are to sketch this graph. So you need to be careful. You are being given that you are to sketch this graph where x is greater or equal to 0. This is the restriction. We call it a domain. You are being asked to sketch this graph where x is greater or equal to 0. Remember that the value of a in this graph is positive. The value of a, the coefficient here, is positive. That means the graph will be concave up. Also, the turning point is at 0. The turning point is at 0. In other words, this function will be concave up. It will be concave up. But then you are to sketch it where x is greater or equal to 0. In other words, you sketch this graph where x is positive. Its turning point is there. So that's how it will be looking like. You want to sketch it this side here. Simply because you are being given a restriction or a domain. You are to sketch this graph where x is greater or equal to 0. Let us now find the inverse of this function. The inverse. Remember, for the inverse, we need to solve the problems. We have y equals x squared. Therefore, x will be equal to y squared. And then this is the inverse. This is the inverse. Let us now find the equation of the inverse. We apply the root sign. Therefore, our y will be equal to plus or minus square root of x. Y will be equal to plus or minus square root of x. Right. Let's sketch this graph. From this graph here, we are to sketch the inverse there. So let us find at least 2 points from this graph. We have x, y. Right. When we are to put -2, this will be 4. It's 4, 1, 0, 1, and 4. Which means we've got 0 is to 0. We only use the values of x that are positive. We do not use those that are negative. So we only use this side here. It's 0 is to 0, 1 is to 1. Let's say we've got 1 here. 1 is to 1. Let's put 2 there. Let's say there is this point, 2 is to 4. 1 is to 1, and then 0 is to 0. Right, for the inverse, we just swap the points. Let's see. Right, let's use the inverse. There, our inverse says x is equal to y squared. So it's minus 2, minus 1, 0, 1, 2. So now we are to check what is the value of that, or what will happen if we are now to swap the 2 points. So from this, x is negative 2, y is 4. That means now, since we are swapping the points, x will be equal to 4 and y will be equal to negative 2. Let's write it as y and x. Since it's the inverse, it's y, x. Right. If y is equal to negative 2, y is 4. 1, 0, 1, and 4. And then we are now have to sketch a graph. Remember that here you are being given the domain. Since now this graph is like that, we are to write the what we call the range. It's y greater or equal to 0, but after we have found the inverse, y greater or equal to 0. That's why we are going to sketch our graph. It will be above the x-axis, not below the x-axis. Right? We've got 0 is to 0 there. And then 1. It's 1. And then it's our 4 there. 1 is to 1. Right. This point here, so 1 is to 1. It's a 4 is to 2. Right. Looking at the two functions, our a is positive and the graph is facing upward. It is facing the positive values of y. Facing the positive values of y. Here, the inverse. Still, the value of a is still the same one. It's positive. That means the inverse will face, or it will be the same as you have seen here. It is facing upward, the positive values of y. Here it will face the positive values of x. Right. Make sure that once you are writing the inverse, you write the range. It has to be above the x-axis. Here, that's the domain. It's x, the domain, y, the range. And let's say you have this function here. x plus 2 all squared minus 4. Let's say we've got that function there. Right, without solving for x, determine the range and the domain for that function. Range and domain. The range and domain. Right, as I said, these are our restrictions. They restrict us on how we are going to sketch the graph. When we look here, we are looking for the value of y. The range is the value of y. That will make this function not to exist. And then you write a restriction from that. For instance, let's say here you are putting negative 4 in the place of f at x. Let's say you are saying f at x is negative 4, like that, equals x plus 2 minus 4. Right. Let's say we've got that. And we are to solve this for x. We have to transpose. It's minus 4 plus 4 equals x plus 2 all squared. This is 0. Therefore, x plus 2 is equal to 0. We solve for x. X plus 2, like that. Therefore, x is equal to negative 2, which means x is existing if this is equal to, if y is equal to negative 4. Right. Now, I want us to put the value that will be less than negative 4. The value that is less than negative 4, it will be, let's take that equation, it's x plus 2 minus 4. We are to put the value that is less than negative 4, which is negative 5. Right? We are to solve this equation. X plus 2 is equal to negative 5 plus 4. X plus 2 all squared is equal to negative 1. We want to solve for x. X plus 2 will be equal to square root of negative 1. This doesn't exist. This doesn't exist. Because we've got a square root of a negative number. The square root of a negative number does not exist. Which means if you are to make y to be less than that value, this won't exist. We said negative 4 there. It's f at x equals x plus 2 all squared minus 4, which is y equals a into x minus p plus q. Yesterday, we said p is to q. This is our turning point. That's our turning point. Therefore, if this is our turning point, then our turning point will be negative 2 is to negative 4. If this is negative 4 like that here, if this is negative 4 and we make y to be negative 4, it will exist. But if this is below negative 4, like as we have shown here, it is negative 5. Once this is below negative 4, it won't exist. For instance, let's say we have a graph with the coordinates negative 2 to negative 4. Negative 2 to negative 4, right? If once you are below this point, when you are below this point, it's where we are saying we have negative 5. Once you are below this point, this graph is not here. It is above negative 5. That's the reason why we are saying this graph is existing only where y is equal to negative 4. Even if you go to this point, this graph is still existing. It is still existing. So it starts to range from this point, from the turning point, upward. It is ranging from this point upward. From negative 4 upward. From negative 4 downward, it doesn't exist. It is not here. It doesn't exist. So that's what the range means. Therefore, if you were to write the range for this, it's simple. You look at the value of y at the turning point and also the value of a there. Right? Let's say the graph is concave down, which means a is negative. A is negative. So the graph is ranging from this side. Remember that this graph can continue there. So it is ranging from this side up to the turning point. From the turning point to this side, it goes down, it doesn't range. It ranges only from this point up to the turning point. Which means here, if you are to write the range, y can be any value. Y can be any value. But that value must be less than the value of y at the turning point. It has to be less than, because it ranges from this point up to that point. So we are saying y is an element of real numbers, but y must be less or equal to this value here, which is represented by q. It's y less or equal to q, the range for that function. Coming back to this one, this is concave up. Concave up, so it has to be greater or equal to negative 4, the range there. Y can be any value. Y can be any value here. That value mustn't be below negative 4, it must be above negative 4, upward, for this graph to range. Y must be greater or equal to negative 4. Must be greater or equal to negative 4. Just to make an example, we are saying it must be greater or equal to negative 4. Let's try to put a negative 3 there, which is greater than negative 4. It's x plus 2. We just want to check if our graph is still existing. It's x plus 2 minus 4 equals negative 3. We are equating our y to negative 3. This is our y, right? X plus 2 all squared will be equal to negative 3 plus 4. X plus 2 all squared is equal to 1. Let's put our square root there. Therefore, x plus 2 will be equal to plus or minus 1. So you can be able to solve for x here. Which means if our y is greater than that value at the turning point here, it will exist. If our y is greater than or equal to that value, it will exist. But once it is less than, once it is negative 5, it won't exist. This graph is not here. It doesn't exist here. It only exists at negative 4 upward. Right, let's check for the domain. For the domain, we are to check if is there any value that we can put it here and make this not to exist for our y. When you look here, we can put any value of x here. Any value. This will always exist. Any value. It's either 0, negative, positive. Therefore, for our domain is the value of x. Remember, x is an element of real numbers. X is an element. You can put any value. This graph will always exist. You can put any value of x. This graph will exist. Since we have said this is our restriction, any value of x, this graph will always exist. Right, let's say you are being given this function. Let's say you've got that function. Without solving for x, determine the range of the domain. We are to determine the range of the domain. Right. Without solving for x, determine the range and the domain. Remember that for us to find the range, we need to see the value of y at the turning point. So here we are to find y at the turning point. It's either we complete a square or we find the x value and then substitute it into original to find y. Right, let's complete a square. It's negative, we are taking out negative there, into x squared. It's x squared minus 4x minus 12. Right, and then this will be equal to x squared minus 4x plus, and then now we have this coefficient. In other words, we divide negative 4 by 2. That would be negative 2 squared. Minus 12. Remember that these have to cancel each other. So if you say on the same side, it's plus this, and then here you have to say minus. We subtract the same value. It's negative 2 squared. And then we close our bracket. G at x will be equal to negative. Let's put the square bracket. Now we are to factorize here. It's x, and then we take that as it is, it's minus 2, and then all squared. Let's come to this one. Negative 2 squared, it's 4, which means we are going to have minus 12 minus 4. That would give us minus 16. And then we are now have to solve the brackets so that our equation will be in a form y equals a into x minus p all squared plus q. So let's solve the brackets again. Negative times this bracket, it will give us a negative. That would be negative into x minus 2 all squared. Negative times negative 16, that will be plus 16. So our equation now is on that form, so we can be able to find the turning point. Remember, we are finding the turning point so that we are going to be able to find the domain in the range. Our turning point will be given by, we solve for x just inside here, it's positive 2 is to positive 16. That's our turning point. Remember, this graph, it has got a maximum value since the value of a is negative. A is negative. Therefore, it has got a maximum value. Our turning point is given by 2 is to 16. 2 is to 16. We are to find the range. This graph is ranging from this side upward. In other words, it is ranging from negative infinity up to 16. From negative infinity up to 16. That's our range. Or it ranges from where y is less or equal to 16. When we say less, is this side. Equal to 16 is there. Therefore, we can write our range as y is an element of real numbers. But those real numbers must be less or equal to this value, which is 16. Or you can write the range as, y is an element of negative infinity up to positive 16. So, we put a square bracket, but here we do not put a square bracket, we put a round bracket to include all the values that are less than 16. So we put a round bracket, and then there we put a square bracket. You can either write it like that or this one. Remember, for the domain, any value of x that you can put it here, this function will always exist. Therefore, the domain x is an element of real numbers. X is an element of real numbers. So let's stop here for the domain and range so that we are going to proceed to transformation.